Definitions. The imaginary unit I is the number whose square is -1. In other words, I squared is equal to -1. And I equals the square root of -1. So that is the biggest definition we can define for now. We have I is the square root of -1. So the square root of a negative number p is, for instance, square root of negative p, which equals I square root of the p. Let me try to explain this a little bit more in detail to make it easier to visualize. If we have negative p to start with, we take the square root of negative p. So in other words, let's call it -1 times p. We can always add a 1 in between there, right? And it's the square root of -1p. How about if we separate this a little? So we have -1 times p, but a little bit of space. And we can distribute this into two individual radicands. Square root of -1 times the square root of p. Hey, look at that. That's our definition of I, right? The square root of -1. So therefore, the square root of -1 can be changed to say we have I times the square root of p. Hence the reason why we have I square root of p. So a complex number is a number of the form a plus b times I, where a and b are real numbers. An imaginary number is a number of the form a plus b times I, and b is not equal to 0, something to be aware. Otherwise, it wouldn't be an imaginary value, right? Keep in mind the imaginary portion is the one that contains the I, technically. Okay, so in this case, let's try solving for the following examples. Some examples to use as a reference. So A, we have x squared equals -4. So this because we want to get rid of the square to solve for x. Agreed? What's the opposite of a square? Square root, right? So if we take the square root on both sides, well, that cancels the square root with the square on the left side, leaves us with the square root of -4 on the right side. Let's keep in mind we can split this up into a -1 times 4 with the square root or a radical sign. Square root, right? How about if we split this up into two individual radicals? So square root of -1 times the square root of 4. Square root of -1 by definition is I. And the square root of 4, well, let's continue to bring it down. What is the square root of 4, by the way? What number times itself gives us 4? 2, right? Let's remember to put our plus or minus, and we are talking about a square root. So technically in our end result or end value, we need a plus or minus, or even in the previous steps, we could have had a plus or minus all throughout. So in this case, we have plus or minus I times 2, technically. Be aware, we typically write the number followed by the letter or the variable in most case scenarios. So no reason why we couldn't put the I afterwards to make it look more of a custom format. In other words, more of a typical format. I should say x equals plus or minus 2I would technically be the best way to answer this one. Okay, let's try the other example, example B. For example B, we have -2 times in parentheses w plus 1 quantity squared plus 7, and that equals 39. So let's get rid of the 7. So -7 from both sides, cancel the 7s, and we got 39 minus 7 gives us 32. So how about we get rid of the -2 now? In other words, divide by -2. What we do to one side, must do to the other, right? So this one will cancel the -2s. There we go. And that leaves us with w plus 1 quantity squared equals -16. Would you agree with that? Yeah, that works. 32 divided by -2 is -16. And now we're taking the square root to be able to get rid of the square. Okay, remember, square root and square cancel each other out. That leaves us with w plus 1. Okay, let's do remember. We can split up the -1 times 16 instead of -16, right? So that we can get the combination of I and square root of 16. But square root of 16, number times itself will give us a 16. Probably 4, right? So there we go. W plus 1 equals plus or minus I times 4. Once again, keep in mind, we typically have or write the I after the number. So therefore, W plus 1 equals plus or minus 4I. Okay, so let's get rid of the 1 to solve for the W. Minus 1. Notice that the 1 does not have an I, right? So technically we cannot combine it with the 4i. Okay, so how do we write it in this format? W equals plus or minus 4i minus 1. Be aware, technically this is correct, but the more common way to write this is to write the number first, then the I afterwards, or number with I, the imaginary portion, I should say. So our final answer, W minus 1 plus or minus 4I, is our final answer. Something to be aware. In some classes, you use I as the imaginary value. In other classes, you may end up using J as an imaginary value instead. It just depends on what class it is, keep in mind. For instance, in electrical or circuits, you use I as the current, right? So you try to differentiate by using a J instead of an I. Something to be aware. But for this case, here are our two forms of solutions, or typical solutions when we have imaginary values.